Good morning. So today we're going to take the next step with what we were working on last time with dilations, and we're going to talk about similar figures. So when you dilate a figure, we had talked about how the corresponding angles remain congruent and that there was going to be a ratio between the sides. So with similar figures, that's what we're going to look at today to be able to determine whether one figure is similar to another or basically it's a dilation of one to the other. So in order to be similar, you need to have two things, basically. So the corresponding angles are congruent. Okay, and the last one is the ratio of the corresponding sides. They also have to be congruent. Okay, now it's not the corresponding sides are congruent, it's the ratio. We'll go over that in a minute. So let's look at these two triangles for a second. And we're going to try to determine whether they are similar or not. So looking at them, again, most of the time you can sort of figure this out. These are drawn to scale. Corresponding angles are congruent in this case. Now what we need to do is look at the ratio of the sides. So again, it doesn't matter which way you go, whether I'm going from smaller to bigger or bigger to smaller. You're going to get different numbers, but the same thing is going to apply. So if I look at 10 and 15, what do I multiply 10 by to get to 15? Well, the correct answer is 1.5. So it's basically 15 divided by 10, okay, which is 1.5. Well, what do I multiply 6 by to get to 9? Again, 1.5. What do I multiply 8 by to get to 12? Again, 1.5. So because the ratio of each side, I multiply each one of these sides by the same ratio, and I get the same numbers here. This would be similar. Now, I can also go from the bigger one to the smaller one. So what do I multiply 15 by to get to 10? Well, that's 2/3. How do I get that? Well, just 10 divided by 15. Okay, that simplifies down to 2/3. 6 over 9 is 2/3. 8 over 12, again, is 2/3. So the ratio is the same. Do you remember we talked about this the other day? It's also called the scale factor. Now let's look at these two shapes. Are these similar? Well, the answer is no. And the reason why is corresponding angles are not congruent. Okay, there is a common ratio of the sides. Okay, every side here is double each side here, or each side of these is half of these. That's fine, but the corresponding angles are not congruent. Therefore, they are not similar. Now let's look at this one. Looks pretty close, doesn't it? Corresponding angles are congruent. Okay. Now let's see, can we find a common scale factor or a common ratio between corresponding sides? So what do I multiply 12 by to get to 24? Obviously the answer is 2. Well, that means if I multiply this by 2, this side by 2, I should get that. And I don't. That's 8. That would have to be 16 for these to be similar. Since it's 18, these two shapes are not similar because the ratio of the sides is not the same. So let's just look at a nice little figure here for a second. Let me put myself in the bottom right-hand corner. So these are two similar triangles. Corresponding angles are congruent. That's what those signs tell us. Now, we also need to understand the ratio of the sides. So this side and this side are corresponding. So this side divided by this side, or in a ratio, has to equal that side, BC, divided by EF, which also has to equal the ratio of this side to that side. All right, do you have to find all of them? No, you just need to take two pairs, okay, if it's a triangle. Because if you have two sides have the same ratio, then the third side definitely will. Quadrilateral is a little bit more in-depth than that. And this is just saying corresponding angles are also congruent. Now we have to determine, all right, so before we looked at two shapes that gave you the side lengths. Here we're looking at two shapes that don't give us the side lengths, but rather are graphed on a coordinate grid. So what we need to do is look at the points. Okay, so this is 0, 3. The corresponding point is 0, 6. 3, 3, 6, 6, 3, 0, 6, 0. So what we have to do is be able to figure out, can I multiply both x and y, this is what we did last time, can I multiply both x and y by one number to get this? Same thing, can I multiply this by the same number I did there and get that? Can I multiply this by the same number and get that? Now, in this case, it does work out that way. So if I multiply, let me just put myself there. If I multiply each point by 2, it winds up being those other points. So since each one of these points, I multiplied the x and the y by the same exact number, got the other points, it is similar. So let's look at this one. What happens if I drew a new triangle? That's not on here, but it has points 0, 4, 5, 4, and 5, 0. Is this similar to these two similar triangles? So that's another thing. If you have two similar triangles and you can figure out that, or two similar shapes, and you can figure out that one of that new shape, a third shape, is similar to one, it will be similar to the other as well. So let's just take these points. Can we get 0, 3 to be 0, 4? What would I multiply 0, 3 by to get 0, 4? Now, it's not a simple number to figure out in your head super easily, but it's actually a little trick that can help you. What do I multiply 3 by to get to 4? It's really easy. Most of you are like, 1.33. Yeah, simple, 4/3. Right? If you multiply this number, to get to this number, you take that number, divide it by that number. It works every time. Okay? So I multiply 3 by 4/3 to get 4. All right, so do I multiply this number by 4/3 to get that number? No. Okay, 3 times 4/3 is 4, so this would need to be 4, 4. All right, and now if I multiply this by 4/3, I would have 4, 0. So since this does not, since I did not multiply the same number to get this one as I did to get this one, as I did to get that one, okay, since they're all different, they are not similar. Let's take a look at this one. Now this one's a little different because even though it's on a coordinate grid, if I were to multiply the points by a certain number, it truly would work, but it's a little bit more complicated. Because it's a rectangle, we're just going to use the side lengths. Okay. So if we take this side length right here, it's a 1, 2, 3, 4, 5, 6, 7. It is a length of 7. Now the corresponding side will be this one because obviously it's the long side of the rectangle. 1, 2, 3, 4, 5. So to get from this side to this side, I would multiply by 5/7. I'm sorry, 7/5. Because this is 7, that is 5. 5 times 7/5 gives you 7. Okay. Well, do I multiply this by 7/5 to get that side? Well, let's see. 1, 2. 2 times 7/5 is 14/5. Well, that's just 2. So since these two, the scale factor between them is 1, from this side to this side, the scale factor is 7/5. Since those two are not the same, it is not similar. Okay, so even though they have the same angles, corresponding angles are congruent, the ratio of the corresponding sides are not equal. That leads us to the final question, is how do we apply some of this stuff? So an artist draws a replica of a painting that is on a remaining piece of the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in the replica is 3.75 inches. What is the height of the trapezoid in the replica? Okay, so the original one is right here. It's 12 inches by 15 inches. Where is it up there? Probably the teeth. Okay, so these two are similar, okay, because it tells us it is a similar trapezoid. So therefore, we know that corresponding angles are congruent, but we also know that the ratio of corresponding sides must be equivalent. They must be equal. So basically what we're doing is we're going to write a proportion. We know that 15 corresponds to 3.75 and 12 corresponds to H. Okay. So in this case, we wrote it as 3.75 over 15. I also could write it as 15 over 3.75. It doesn't matter which way you do it. You just need to be consistent in both sides. So in this case, we went from the smaller one to the larger one. So therefore, we had to do the smaller side there to the larger side there. So now we just have to solve this. We did this earlier this year, right? So I have h. How do I find h? Oh, well, I don't know what h is, but I know what h divided by 12 is. So what am I going to do to both sides? Multiply by 12. Because I'm multiplying both sides by 12, it will eliminate my 12 here. It really doesn't go away. It just becomes 12 over 12, which is just 1, so it gives us 1h. So I multiply both sides by 12, and it comes out to be 3. Now, I'm not going through all the multiplication. Yes, you can cross cancel, blah, 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 move on. Not really that interested in that right now. Your calculator can calculate that for you. Okay, so what did we do? If we know they're similar, you can write a ratio with corresponding sides, okay, comparing one corresponding side to the other, and that'll get you to the answer. Good luck. If you have any questions, please reach out. Bye.